to sketch a few graphs basing information on vertical asymptotes and some horizontal asymptote business. See if we can get an idea about what these graphs look like. I ask you to try questions 2 and questions 3 over the weekend. However, 4 and 5 are definitely fair game. So I'm going to say you can try those if you want for extra practice. I'm not going to work through 4 and 5, but I'm going to work through the solutions for 2 and 3. All right. So we'll start with question 2. Okay, so I'm going to write it out here. So we've got this rational function, and we've got, oh, I'm already messing up. So we've got some rational function, and we've got x on the top, and x plus 1 over x minus 2. Okay. So we went over a few basic steps for approaching these in class. We started with look for the domain. Restrictions. Nope, that is, we'll turn that into an R, restrictions. So we know that the denominator can't be 0. So we're going to say x plus 1 times x minus 2 can't equal 0. So then the conclusions we make are, well, then that means that x can't be 1. Oh, no, x can't be 1, x can't be negative 1, and x can't be 2. All right, and so we're going to make those into vertical asymptotes. At x equals negative 1 and x equals 2. So we'll sketch those on a set of axes here. And we'll say, how do you graph that x can't be negative 1? Well, there are a couple of ways, actually, and we're going to look at a few more later this week, but the one we talked about is when you are trying to divide by a value and it makes the whole thing 0. We're going to represent that as a vertical asymptote. And we'll look at some exceptions later. X equals a negative 1. We'll label it with the equation. And also the value was 1. This is x equals 2. And these dashed lines, they're not part of the graph. They help shape the graph, but they're not part of the function itself. They actually denote the borders of the function, the parts the function can't be. Okay. So then we said, okay, what about when x gets big? Okay, so we chose some values for x and some values for y. And we chose an arbitrarily large value for x. I might choose 100. And that means y is going to be 100 divided by 101 minus 98. 100 divided by 100 plus 1 is 101 times 100 minus 2 is 98. That gives me 0.0101 ... Okay. So I'm not super comfortable concluding for sure where x is, pardon me, where y is going to at this point. So I'm actually going to choose a bigger value of x. I'm going to say 1,000. I'm going to find out what happens when we divide them by 1,000. So I'm actually going to write, in case anyone is looking at the answer key but not the video, I'll just write that in here. So now I'll divide 1,000 by 1,001 times 998. Alright, so what do we got here? 1,000 divided by 1,000, 1 times 998. And, okay, I get something in scientific notation. I don't actually want this in scientific notation right now, so I'm going to see if I can turn off scientific notation. So I'm going to go to mode, regular, Let's try this one. I think this might do it. Let's just try it. Dang, still scientific notation. Okay. Okay, fine. We'll just do it in scientific notation. I don't want to waste much more time. All right. So this gives me 1.001003 times 10 to the negative 3. That's scientific notation. So what that means is that if I want to write this without scientific notation, I'm going to shift this decimal point to the left once, twice, 3 times. For the number negative 3. It goes to the left because it's negative. It's moving in the negative direction. So actually, that means that this number, if I fill in these gaps with zeros, I get 0.001001003. Dot, dot, dot. Okay, so I've got 0.00100 dot, dot, dot. All right. Now let's say I'm still not confident in where my y's are approaching as my x's are getting really big. So I'm going to choose 100,000. See if I can get extra certain what this value is approaching. So let's go 100,000 divided by 100,001 divided by 999,998. Whoops, no, too many nines. Yeah, 99,998. Oh, I did it twice. Oh god, I hate this. Open bracket. What are we doing? 100. On. Good. Times 99,998. Okay. So I get the same thing times 10 to the negative 5, which means I'm going to add an extra 2 zeros in here. 0.000100001. Dot, dot, dot. Okay. So I think as x gets really big, y approaches 0. Oh, I used a symbol for null. That was bad form. Sometimes I do that by accident. Y approaches 0. The number is 0. Okay, so that means we also get a horizontal asymptote, we think, at least in the positive direction, at y equals 0. So it looks like y equals 0 is a value our graph is going to approach but never reach. Okay. What about when x gets really small? So we'll choose some values like x and y. Okay, so before we get here, what we've concluded here is that when x is, say, 100, y is a little bit above 0, but positive. And when x is 1,000, y is still a little bit above 0, but not much. So I got these values, and they're just above, but they're never going to reach an asymptote. Okay. Let's see if we can get the rest of this graph then. So when x is really small, we'll choose, say, x is negative 1,000, and see what we get. So it'll be negative 1,000 on the top over negative 999, because 1,000 plus 1 is negative 999. Negative 1,000 take away 2 is negative 1,002. So, okay, I'll get negative 1,000 divided by negative 999 times negative 1,002. I get negative 9.99 times 10 to the negative 4. So again, we'll move this decimal place over once, twice, 3, 4 times. So it's actually negative 0.0000999 002995. Dot, dot, dot. Okay, so I could think this is also approaching 0 on this end as well. Okay. As x gets really small, y approaches 0 as well. And I know that when x is negative 1,000, it's a little bit below 0, but not much. So it's a little bit low. All right. So I would say we know that the asymptote is 0, the horizontal asymptote. Great. Okay. Now, let's test some values. Let's get an idea of what this thing looks like. So let's choose some nice numbers here. Let's do some test points. So I'm going to choose some values for x on the left-hand side of this asymptote, in between these two asymptotes, and on the right-hand side of this one. I already have a theory about how some of this graph's going to shape together. Maybe you do too. And we'll just test these to confirm some theories. All right, so let's just do some x's and some y's. So I'm going to choose a couple of values here. I'll choose x as negative 3 and negative 2. I can't choose negative 1, obviously. But I'm actually kind of curious to know what happens between the y-intercepts. I'm actually going to choose negative 0.5. I'll choose x as 0 and x is 1, and see if I get a figure out what's going on in there. And we can't choose x as 2, but we'll choose x as 3, and we'll choose x as 4. And that should do us. All right, so I'm going to play around with some numbers here. So when x is negative 2, 3, negative 3, negative 3, I'll divide that by negative 3 plus 1 is negative 2 times negative 3 minus 2 is negative 5, and I get negative 0.3. So when x is negative 3, I get a point here at negative 0.3. All right, and when x is negative 2, I get negative 2 plus 1, or negative 1, times negative 1 minus 2, which is negative 3. And I get negative 0.666. So I get something a little bit closer to 1, negative 1, pardon me. Okay, it's interesting. I'll write that in here. Negative 0.66. Dot, 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 dot. Huh. All right. I kind of have an idea what's going to happen here because I know that graphs are shaped by the asymptotes that surround them. If I wasn't convinced, I might try to plug in negative 1.5. Maybe I'll put in negative 1.5 as well, just to be sure. But I already kind of have an idea. So we'll do negative 1.5. We'll divide it by negative 1.5. Negative 1.5 plus 1 is negative 0.5 times negative 1.5 minus 2 is like negative 3.5, right? Yeah, negative 3.5. Nice, so again, negative. Okay, so here it's a little bit closer to 1 even still. Funny. That's really funny, actually. I kind of want to choose a point just to the left of 1 now. So I'll write that in here. Negative 0.86. So the reason I'm doing this is because I actually had this hypothesis as we got closer to this asymptote. This guy would approach down to negative infinity, but it's not really growing that fast. No experiences these guys grow a little faster. So I'm actually going to try one more. I'm going to try negative 1.01, a number really close to the asymptote, and make sure I can get a really clear picture here. So negative 1.01, I'll divide it by, so what am I going to get here? Negative 0.01 plus 1 is like negative 0.01 times negative 0.01 minus 2 is like negative 3.01. All right, so we get the negative 33. All right, so that means this guy's way down here somewhere. All right, so we're getting some sort of shape. Looks like this. And it'll be trying to reach that asymptote, but never will. All right, so let's test some other points here. Negative 0.5, we'll divide it by negative 0.5 plus 1 is 0.5 times negative 0.5 minus 2 is negative 2.5. And I get negative 0.4. Okay. So when x is negative 5, I get negative 0.4. And when x is 0, I plug in 0 here. Oh, I get 0. Nice and simple. When x is 1, I'll get 1 over 2 times negative, okay. 1 divided by 2 times 1 minus 2 is negative 1. I get negative 0.5. Okay. Well, what happens in between there? 0.5. Uh, 0.5 divided by 1.5 times 0.5 minus 2 is negative 1.5. Get negative 2.2. Okay, weird. Negative 0.22 dot dot dot. All right, so my intuition says it's gonna do this. And I think I'm comfortable enough doing that just based on my previous experience with asymptotes. But if you aren't comfortable, just pick another few points and test them. Okay. Lastly, we'll choose values that are above 2. So we got, oh, we forgot 1. Test that. That was like, I forget. 1 divided by 2 times negative 1, negative half. Okay, so next is 3. We'll do 3 divided by 3 plus 1 is 4 times 3 minus 2 is 1. I get 0.75, so next is 3, y is 0.75. And let's say 0.75, y is 4. We get 4 divided by 4 plus 1 is 5 times 4 minus 2 is 2. I get 0.4. Next is 3, I get, okay, so I'm starting to get another sort of situation, something like this. All right, and then we should check and check with Desmos. So I'm actually going to double check that I don't have anything funky going on in my own graph, as I recommend you do. Because it really doesn't hurt to use a tool when you have a good tool. X divided by x plus 1, x minus 2. Oh, okay. I must have miscalculated a point. And it was this point. I'm just going to test that again. Negative 0.5 divided by negative 0.5 plus 1 is, it's 0.5 times negative 2.5. There it is. So it's actually positive 0.4. That explains that. So that guy is not here. And when x is negative 0.5, we get positive 0.4. And now we get a shape more like I was expecting. All right. And in case you were wondering what the Desmos picture looked like, I think I can show you maybe. Not sure how this will resolve, but I'm going to try to put that in there and you can have a look. And you can see the asymptotes here. And of course it won't show the asymptotes, but it will show that it's approaching a value and never reaching it. And you can zoom in if you like and see if it's approaching that value. And you can test points. Oh, there's our point when x is 1, it's a negative 1/2, just like we found, and so on. I hope that resolved. I won't be able to test until after I watch the video. Okay. So there we go. There's our graph. So we're going to go back, and there we go. Pull that up. All right, so let's move on to question 3. So we're going to see if we can repeat that process and maybe expedite it a bit because I think we went through that a little slowly. And for question 3, which I may need another piece of paper for, maybe I'll do it on the back here. Okay, so what do we have? X plus 2 over x minus 1 squared. So question 3. We have y equals x plus 2 over x minus 1 squared. Now, first thing to remember is that this means that there are 2 roots. So it's actually x plus 2 over x minus 1 times x minus 1. All right, that may or may not become relevant. We're going to not get too hung up on it, though. All right, so is there a domain restriction? And there is. There's one at, well, we know that x minus 1 squared can't equal 0. And that means that x, or pardon me, 1, x can't equal 1. So then we get to conclude there is a vertical. We get a vertical asymptote at x equals 1. So we're going to graph that here. And I'm going to do some nice spacing here. 1. And there's our asymptote. Then we'll ask some questions like we'll look for our horizontal asymptotes. By asking what happens when x gets big. So we'll check some values, and we'll take, say, 100. So y is going to be 102 divided by 99 times 99. And we get 0.0104. Okay. I might check another value, x is 1,000, and I get 1,002 over 999 times 999. And I get 0.001004 dot dot dot. Okay, so I think this is approaching 0 for y. So we get a y value. Y equals 0. I'm going to test a negative value. X we'll choose negative 1,000. Let's do negative 10,000. So it's going to give us negative 9,998 over negative 1 times negative 1,0,0,0,1. All right, so we get a really small number. We get 0.0009996 dot dot dot. Okay, so and it's negative. Equals negative. So again, it looks like we're approaching 0. Okay, looks good. So now I might choose some test points. So 4. I already have an idea of what this is going to look like. I'm going to choose, say, x and y values such that x will be, let's say, negative 2, negative 1, 0, and a half. And then I'll choose some numbers on the right-hand side of this asymptote as well, like 2 and 3. And that should be enough, I hope. So when x is negative 2, when I plug negative 2 into this equation for x, I get 0 on the top. Well, actually, that's a 0. When x is negative 2, y is 0. Okay. Well, let's see what else we get here. That's weird. I wasn't expecting that. All right. When x is negative 1, we get negative 1 plus 2, or 1 on the top, over negative 1 minus 1 is negative 2 times negative 2, which is a quarter. Okay. When x is 0, y is 2 on the top, and negative 1 over negative 1, which is 2. So we get a value at 2. Oh, I'm not really drawing this as scale. 1 should have been up here, I guess. All right. And I'm interested in what happens at a half. So I get a half plus 2 is 2.5 over a half minus 1 is negative 0.5. Negative 0.5, which is 2.5 divided by negative 0.5 times negative 0.5, and we get 10. This is way up here. All right. And lastly, we'll choose x to be 2. 2, 3. X is 2, we'll get 4 over 1 and 1, which is 4. 2. And when x is 3, we'll get 3 plus 2, which is 5 over 2 times 2, which is 5 over 4, which is 5 quarters, or 1.25. Okay. So I have an idea. It's probably going to look something like this, approaching these asymptotes. However, this one passes the asymptote at the last moment. So I don't really know what's going to happen here, so I think it's worth testing a few more points. I see it's eventually going to try to approach 0. What's going to happen here, though? What's going to happen in negative 3? I'm a little curious. This is what's going to happen when you're graphing these. Sometimes you're going to get erratic behavior, unusual, and it's going to just require you to take a second to test. And that's okay. X is negative 3. We got negative 3 plus 2, or negative 1 on the top. Negative 3 minus 1 is negative 4. times negative 4, and I get negative 1 over 16, which is negative 1/16. That's already quite small. Negative 0.0625. All right, so it's down here. Negative 4. I'll try negative 4 as well. Negative 4 plus 2 is negative 2, so I'll get negative 2 on the top. And I'll divide it by negative 4 minus 1 is negative 5, so again, oops. Negative 5 times negative 5, and I get 0.08. That's a little bit bigger in negatives. It's still getting a little further away from the y-axis, or x-axis, pardon me. That's interesting. I'm going to try, wait, let's just look here, 10. Hmm, 7 over 36. Where does this ratio change? Okay, I can see that. 12 over, interesting. I'm going to try a negative 10. Oh, shoot. Equals negative 0.0826. Weird. Okay. So out here at negative 10, we're a little bit further still, but something tells me we're getting closer, like we might have dipped below. This is a funny looking graph, though. I'm going to try negative 100. Plus 2, which is negative 98, divided by negative 101 times negative 101. Okay, now we're getting back to approaching 0. Okay, so funny looking graph. Came down and starts approaching 0 from the bottom. And that happens sometimes. And you just got to keep testing it until you get values you like. We'll test it with Desmos, and this may be a ridiculous thing for you to watch if this doesn't actually resolve for you, so I apologize. Alright, so I zoomed in a little bit because I was curious about what happens at this axis. So we see some pretty similar behavior. We see some big growth as an asymptote of 1, this guy above here, zeros where we found them, a y-intercept where we found it, and a root. And it looks like it dips below a little bit and then starts coming back up and approaching the x-axis from below. Okay, and there's our graph. All right, so a little playing around with some of these graphs, and that's okay. Let me know if you have any questions about any of these, and we can go over them. Good luck studying.